Introduction. Our group project is a design major handy system at jetty Kampung Tebelu to transport fish and shrimp from the jetty to the processing center. This project to minimize the manual labor. Our group proposed manual twin arm lifter to lift the basket from the boat to the jetty and from jetty to the processing center. We implement the CABLEWAY system with the semi-automated operation.
Our first problem segment is power supply is far away from the jetty, which is at the processing center. And the second is environment effect, which is the wind effect and also the corrosion and so on. And the third one is water level, which is the boat and the jetty is have a different water level, so it heavy and difficult to us to load and unload process at the boat to the jetty and also the processing center.
I will briefly explain about material selection that we done in Engineering Design 2. ASTM A500 is chosen as the material for cableway and twin arm lifter after comparing it to two other materials, mainly because it has higher yield strength. For wire rope material, galvanized carbon steel rope is chosen based on the table provided by ISO 4375, which guide the cable selection for various suspension loads. For mechanical analysis of twin arm lifter, we calculate the safety factor and its allowable stress. By using the dimension of the rectangular hollow 75 times 25 mm with the thickness of 4 mm, it increased the actual design factor from 3 to 3.13. For suspension cable, a factor of safety of 5 is required by ISO 4375. Hence, the initial tension and working tension is calculated. The initial tension factor of safety is 6.47 while the working tension is 9.12. Since both safety factors exceed the recommended factor of safety of 5, the system is safe.
Hi, my name is Fana Balai with metric number 65987. I will explain fluid analysis and thermodynamic analysis. For fluid analysis, I will explain wind effect, hydraulic system, and hydraulic fluid selections. Wind effect. The cableway system is located at the open areas which make the basket to swing during the transportation process. The average wind speed in the pitching is 4 miles per hour, and from the calculation, the wind force that excited to the basket is equal to 0.99 newtons. Headwind blows against the direction of the basket travels, and crosswind blows perpendicular to the direction of travels. For the headwind effect, the basket will excited to the angle of 0.14 degrees due to the presence of wind. Wind will make the basket vibrate at the cableway system and cause the frequency equivalent to the system natural frequencies. At the angles of 0.14 degrees, the natural frequencies that our group get is 4.43 Hz. Resonance occurs when the frequency of stimulations corresponds with one of the system natural frequencies. When resonance occurs, it will make the system to collapse. The resonance frequency that our group get is equals to 8.9 Hz. Hydraulic system. The hydraulic system is applied on the twin uplifter. Twin uplifter is conducted using a manual hydraulic system. Since the twin uplifter can lift 2 baskets of fish, the total pressure is 7,710.17 Pascal. The time taken for the workers to lift the 2 baskets from boat to the jetty at maximum lifting of 1.5 meter is 37.5 seconds. 36.79 joules per second of human powers is needed to lift the 2 baskets using twin arm lifter until it reaches 1.5 meter. Hydraulic fluid selection. Hydraulic fluids are important for the lubrication, heat transfer, and contamination control. The most suitable hydraulic fluids for the hydraulic cylinder is mineral oil-based fluids, since it has the highest viscosity that is suitable for high pressure environments and low bulk modulus. For the thermodynamic analysis, this section will explain the cooling of electric motor, bearing friction, thermoanalysis of bearing, and thermoanalysis of wire rope. For the thermodynamic analysis, this section will explain the cooling of electric motor, bearing friction, thermoanalysis of bearing, and thermoanalysis of wire rope. For the thermodynamic analysis, in electric motor, all 3 kinds of heat transfer, which are conduction, convection, and radiation, is present. The diagrams in the left side shows the control volume of electric motor. From the calculations, the housing temperature of motor that we get is equals to 63.06 degrees Celsius. Bearing is the high spinner unit that acts as the main source of heat generation in the CABLEWAY system. The analysis at the left side shows the calculation of rolling and sliding friction that act on the bearing by referring to the SKF bearing textbook. From the calculation, it can be seen that the value of rolling friction is lower than sliding friction. Almost all friction loss in the bearing is transformed into heat within the bearing itself and cause the temperature of bearing to rise. The figures in the left side shows the calculation that has been done. From the calculation, the thermal value of rolling bearing is equal to 4.6 times to the power of negative 3 watt, and sliding bearing is 2.669 times 10 to the power of negative 4 watt. The wire rope that was used at the CABLEWAY system will experience thermal expansion during the hot day. The expansion of the stainless steel wire rope of the CABLEWAY can be easily calculated by applying the corresponding thermal coefficient of stainless steel. Based on the calculation at the left side, the expansion of wire rope along the 100 meter of CABLEWAY is equal to 3.44 millimeters.
We have done motor selection by calculating two conditions, which is dry condition and wet condition. As you can see, the maximum power is 1694.22 at dry condition. So motor specification, we choose a motor that has 3000 watt because when the motor is operate continuously without stop, it will overheat. And to ensure the safety factor, we choose motor with higher power, and also we consider the environment factor, which is drag force, wind speed, and also the corrosion. This is the flow chart for the process. First, we switch on the power and then motor will rotate. We can control the speed of the motor. If the wind sensor detects higher than 4 mph, the LED buzzer will alert the operator to control the speed become the lower. And we have ultrasonic sensor also. If the ultrasonic sensor detect 1.6 meter basket from the processing center, it will reduce the motor controller automatically. And if it higher than 1.6 meter, the motor rotate as controller speed. And if we have emergency condition, we will push the emergency button to stop the motor. This is TinkerCAD Simulation for our component. For the first component is potentiometer, is act as speed controller of the motor. And the second one we have function generator. Function generator act as wind sensor because in the TinkerCAD we don't have the wind sensor, so we use the function generator. If the wind speed is higher than 4 meter per hour, we will push the button to trigger the LED and piezo to be on. And the last one, we have ultrasonic sensor at the processing center. When the basket is lower than 1.65 meter, the motor will be slow and we will unload the basket. And the last one, we have push button as emergency button. If there any emergency condition, we will push the button.
Hi, my name is Muhammad Syamsul Syamizan bin Muhammad Nasuha with the metric number of 64968. So for the simulation analysis, as mentioned before, we are come up with the idea of using twin arm lifter and cableway system to transport the fish and shrimp from boat to processing center. In this part of analysis, I use SolidWorks software to run the simulation. For the first step, once the boat comes at the jetty, the fisherman has to fulfill the fish and shrimp into the basket given, and then put the basket at the claw of twin arm lifter. And then the basket will be moving upwards by the mechanism of manual hydraulic pumps. Once the basket reaches approximately at a height of 1.5 meter, the basket will be attached onto the nearest hook at the rope of the cableway system. Then the cableway system will bring the basket to the processing center. This process will keep continue to the other basket. Once there is nearest hook pass through, at the rope of cable system. To test its strength, we use the software of ANSYS to stimulate the maximum stress for each system to be determined. For the first system, which is twin arm lifter, since we apply the load at the claw, so we choose the surface of the claw to be stimulated at the ANSYS, and we get the result of 1.6565 megapascal for the maximum stress and 3.4797 times 10 to the power of negative 11 megapascal for the minimum stress. The value for the maximum and minimum stress are within the range of elastic change. So the life cycle of the claw lifter is increased, as we can say that this is long-lasting claw. This is the simplification version for the realization of the real situation of stress. But if we use bolting as a medium of connection, the value of maximum and minimum stress could be more. As a short discussion, based on the result from ANSYS, we could recommend to add another truss at the claw holder to reduce the possibility of higher stress occur. This is because we are dealing with the environment of sea, which is have a high possibility of erosion. So the second recommendation is to avoid erosion happen, especially at the high possibility of higher stress occur, such as at every angle of the design, as shown. Coating is the best way to use. For the second system, which is CABLEWAY system, we applied the load at the middle between two poles. Since the maximum number of baskets between two poles is 1, so we choose the middle surface of the rope to be stimulated at the ANSYS, and we get the result of 15.232 megapascal for the maximum stress and 6.5628 times 10 power of 16 megapascal for the minimum stress. The value for the maximum and minimum stress, or we can say that the value for the tension are within the range of elastic change also. So the life cycle of the rope is increased, and we can say that it is long-lasting cable rope. This is the simplification version for the realization of the situation of stress. Next, I will talk about manufacturing analysis. This is our production layout, which is consists of 11 parts starting from entrance until the storage room as shown in this video. We use the software of SketchUp to illustrate our production layout, and the result of illustration is shown in this video. For the material handling system, as you all know that material handling refers to how material and goods are moved, protected, stored, and controlled throughout the manufacturing, warehousing, distribution, consumption, and disposal process. So in our company, we decided to use 3 types of material handling system, which is semi-electric stacker, goods trolley, and cargo van. Semi-electric stacker used to deliver the final customization of CABLEWAY pole bracket holder, steel roller, twin basket claw, basket holder, and hook and the hook holder with roller into the manufacturing plant through the retrieval section, which is located in the raw material storage department, while goods trolley is used to convey frequently used items from one section to another section. And lastly, cargo van is used to transport the final product to the working site. For example, in this situation, to deliver CABLEWAY pole bracket holder, steel roller, twin basket claw holder, and hook holder with a roller at Kampung Terbelu. Next, for the storage system, we are using 2 types of storage system, which is heavy duty racking and medium duty rack. Heavy duty racking used to store raw material such as metal used to manufacture hook, bracket holder, and other components, while medium duty rack used to store raw material shaft, screw, bearing, and component received by external manufacturers in manufacturing plant. We also assign some of our design to be subcons, which is pole and twin arm lifter frame. We subcon those 2 design to reduce cost for manufacturing the component, reduce the storage cost for the company, and it is more reliable and also least risky, as the subcontract company may have more experience and skill in manufacturing the component.
Economic analysis cover total cost of project, economic efficiency, and sustainability. Total cost of production is the sum of fixed cost and variable cost. Fixed cost is the cost, not a variable due to the increasing of the production rate, and the variable cost is the cost that increase and decrease due to the change of production rate. Total project cost is Rm 574,360 ringgit 20 cent, approximately 50% for the profit of the company for the material handling system. So the total price to sell to the client is Rm 861,540 ringgit and 30 cents. Economic efficiency cover economic efficiency and physical efficiency. For the economic efficiency, this project is 1.5, which is greater than 1, thus the production achieve economic sustainability. For the physical efficiency, the physical of the manufacturing towards the raw material to achieve the environmental sustainability. The physical efficiency is 98%. Sustainability Development Goal. First, SDG 6 is the enhancement of water quality. In this material handling system, the waste from the project can be recycled where it can minimize the water pollution. Next is SDG 12 is about the consumption and the production. From the physical efficiency, 98% the production of the product increase when the physical efficiency increase. So the optimizing the material is achieved. Hence, we can reduce the source of environmental issue like global warming. Next, the SDG 13 is about the climate change. The environmental and health implication from the waste of the raw material in this project can minimize due to the high percentage of physical efficiency by implementing the production standard and manage the waste effectively during the manufacturing process.
In this section, I will explain about ethics analysis. The Code of Professional Conduct stated that a registered engineer shall at all times hold paramount the safety, health and welfare of the public. To do so, we can fulfill the responsibility to society by putting priority on public safety and health. We also must fulfill the responsibility to environment by taking reasonable steps to reduce possible adverse effects of professional engineering services on the environment. In this project, we prone to choose more environmental friendly material as a way of taking care of the environment. Next, we also have to be responsible to the profession and uphold the honor, integrity and dignity of the profession. To comply with the requirement of Factory and Machinery Act 1967, a machine needs to fulfill the following safety requirement. The first requirement is provision relating to safety. We must comply with the project workflow and build a well-organized production layout to accomplish a variety of tasks safely. The second requirement is subjected to Section 12, lifting of weight, where it stated that no workers should move heavy load that can cause injury to them. To comply this regulation with the project, twin arm lifter and cableway system will be used to transport the product to minimize the risk of accident during the transportation process. The last safety requirement is provisions against fire. In this project, precaution step is taken throughout the whole process so that no unexpected situation can lead to sparks and fire. There are 5 common safety guidelines to avoid disastrous incident while using twin arm lifter and cableway system. First is to inspect both equipment and the load before operating or lifting the equipment. Next is to ensure no workers in the cableway operation area and beneath the load while the equipment is being operated. The third one is to ensure adequate time has been allocated to avoid rushing the task. The fourth one is to ensure cable system equipment is only operated by qualified workers with the proper certification and hours training on the equipment. And the last one is to review safety checklist before operating the transporting process. The team have provided precaution notice and warning on the certain part device to ensure that the public and the workers are aware of the danger while running the system. There are 6 different safety signs for various safety purposes. The last section is the environmental effect of material. The material used for cableway and twin arm lifter are 100% recyclable and can be recycled to create new products without losing its value. It will be difficult to distinguish between recycled steel and new steel of a comparable type. The other material used is galvanized carbon steel wire rope. Galvanizing does not contribute to water pollution in streams, lakes, rivers or seas. It is one of the most environmental friendly material currently accessible and can be fully recyclable when it reaches the end of its useful life.